Hey class. Today we will be going over generic model adaptive families, and they're basically the same thing as the current panel pattern-based families that we've been working on the last couple weeks, but they're a little bit more specific. They can be customized a little bit more, and pretty much if you want to apply like two different panels to a wall system, or you want to create custom edge panels, these are really good at doing that, being a little bit more specific with your parametric, double curvature, complex curvature surfaces, and panelized surfaces. So what we'll do, create a new project just like we've been doing. New template file, and then doesn't really matter, we'll just move our roof up. We'll only need 2 levels, so we can delete level 2. And then if we go to a 3D view, just going to create a really basic double curved surface in the massing environment. So we'll create just a real single curve on the first level, and then we'll set the work plane on the top level. Let's create a curve the opposite way, and then kind of make sure that they're over top of each other in kind of a cool way. There we go. All right, and then we'll just select both, create form, and we got a nice simple double curved surface. And like we have been doing, we'll select the surface and divide it, and then we get our basic UV grid. Now, with what we have been doing with curtain panel pattern-based families and the patterns, typically we would go in, change it to a pattern, then go in and create a panel based upon a pre-existing pattern, like we've been doing. But with the adaptive families, the generic model adaptive families, we're actually creating it from scratch, and we're essentially creating it with these custom nodes, these placement nodes essentially. So for a rhomboid panel, for the rhomboid pattern, each panel has 4 nodes, and you'll remember that from if we go in just for an example and open up a current panel pattern-based family. So we have 4 nodes, and if we switch to a rhomboid, you'll see that you have the 4 nodes, 4 placement nodes, and you have your reference plane that create the rhomboid. You'll also notice that this rectilinear grid is still there, and the rhomboid pattern is built upon this rectilinear grid, this UV structure. The reason why I'm bringing all this up and pointing this out is that for the adaptive generic models, we'll be essentially taking a base grid of nodes and applying the panel to those nodes. So the first thing that we have to do in applying these families is select the pattern, the divided surface, and up at the top you have surface representation, and you can see either the pattern or the surface. So if we select surface, it's going to overlay the UV grid. Every surface that's divided has a UV grid overlaid onto it. It doesn't matter what pattern you select, it's always going to have that UV structure, because that's how Revit and any kind of modeling software builds a surface, is with this UV structure. And if you look, you can see that UV structure, it the node is every 2, so the node of each rhomboid pattern is every 2 panels. Same thing vertically. And if we look at the pattern-based family, that's the same thing, right? So every 2 U grid, there's 2 nodes. Every V grid, every 2 V grids, there's 2 nodes. So it skips one. It's important for when you are applying these nodes. So have both. You can either keep the pattern on or turn it off. It doesn't really matter. What you need to do is select that surface, make sure that is selected, and then at the bottom right next to the surface representation, there's a little arrow, the display properties. That'll bring up a little little panel that has a couple of options. If you go under the surface tab, I typically will turn off UV grids and turn on the nodes. You must have nodes turned on so that you can apply the family that we will be building. So select those nodes, turn those on. All right, these will be the basis for our panels. Now, we've set up our conceptual mass and our surface so that they can have the adaptive panel applied to it. Now we actually have to build the panel itself. So finish the mass, that's okay. It's not a solid form, that's fine. We'll need to open a new family. So new family, and then down under generic models, up at the top is adaptive. So if you open this up, so we're open up to basically a blank model. It's kind of similar to this guy, except there's no pre-existing panel or pre-existing patterns. So what we can do first is essentially build the nodes. So if we're trying to build a rhomboid pattern or a rectilinear pattern or whatnot, we'll obviously need 4 nodes. If we're trying to build a triangular pattern, we're going to need 3 nodes. So how to build these nodes is pretty simple. You'll just need a point element. So up at the top, select that point, and then we'll just place 4 nodes. Doesn't really matter where on this starting plane. And then if you select each of the nodes and hit make adaptive, then they will turn into those nodes that you're familiar seeing in the pattern-based family that have the 3 planes associated with them and whatnot. So the one thing to make sure is make sure that they're in order, either clockwise or counterclockwise. It doesn't matter, but just make sure that 3 is not over here and 2 is not over there. Make sure it's in order. It's pretty easy to change the number. Just hover over here, hit 2, and that will actually change the corresponding number to 2. So 1, 2, 3, 4. All right, and yeah. So now we've created a nodes. Now what we need to do is create that outer boundary, essentially. So what we can do, just like we've done in the past, actually we might not have done this, so I'll review it again. So the big thing with this is when creating these panels, I think we've done it, but creating a spline through points, using the spline through points tool to make sure that the line work that we're creating and subsequently the geometric forms that we're creating from those lines are tied to the adaptive nodes, which are what are hosted to the surfaces, which manipulate themselves to the curvature or to the geometry of that surface. And so we need to make sure that everything is linked together. So we use the spline through points tool, and make sure you only select 2 points at a time. Otherwise you'll get a curved surface or a curved line, excuse me. So spline through points. And then before we deselect, I mean, you can deselect if you want, but I always do it right right after I do the spline through points is over at the right with the line selected is reference line. If you check that, then that turns into a reference line. That will then not show up in the model itself, but it also has a couple properties that we'll use to generate our panel. So do that for the corresponding 3 lines. Spline through points is reference line. If you deselect for whatever reason, just make sure that you tab into that specific line and just hit is reference line. And then one more time, and we're all good. So now we've basically recreated this guy, right? So now what we want to do is create a parameter, right? So one of the cool things about these is there's some parameters that are already embedded within certain elements. So if we select the point element, and then we go in and we set the placement plane to this, and make sure you set the placement plane. So set on that horizontal plane, and then select the point. Make sure that it is selected to the point, not the curve, but the point itself, that little magenta circle with the X through it. Make sure that's highlighted, then select the point, and then do that for the rest of the, actually I'll do it right now. So if you tab in, of course I had it, there we go. So make sure you select the point. If you are selecting the adaptive node, it's all 3 planes are going to highlight. So make sure that you tab in and grab that point. And then over at the right, underneath the properties, there's an offset parameter already set. And what we're going to do, so let's just first change it to, let's say, 2 feet. So this offset specifically is offsetting the point from that horizontal plane 2 feet. Now, if you want it to go the opposite way, let's say we want it to offset to what would be the interior of the wall, all we have to do is change that number to a negative, and it will go down below the horizontal plane 2 feet. We want it above for right now, and actually let's change it to like 5 feet just so it gives it a nice depth. And then hit that gray box next to it and create a parameter. Let's just call this offset. Make sure it's a type for right now. Hit OK, OK. And then we'll essentially do that same thing for all 4 points. Select the horizontal plane. Make sure that you place it on the node itself, the center node, and then change this parameter to the offset parameter. And now it'll offset that same exact spot. Do that again for all 4 points. Oops, see, don't want to do that. I accidentally selected it on the line. One more. All right, so now we have those 4. What we'll do with these is literally the same thing that we did with the nodes, spline through points, make them a reference plane, or a reference line, excuse me. There's a lot of repetition in this, but it's all important in making sure that the panel itself and all the geometry associated with it is adaptable and linked to those those initial nodes so that they form and manipulate themselves to the surface. So now that we have that, what we're going to do is essentially create an offset from the interior to the from the outside boundary of the panel to the inside. And what we'll do is we'll take the point tool and place 2 points on either side of the panel, and then actually, sorry, scrap that. Sorry, I'm thinking through a couple of things. What we're gonna do first is place a point on all 4 of those lines, and make sure that they're kind of close to the corresponding node, so they're all kind of closer to one side, rotating around in a clockwise direction. And then if you select those points, one of those points, since you've placed it on this reference line, a couple different dimensions are going to come up. And one of those, under properties, is the normalized curve parameter. This essentially tells the point where exactly on the reference line from 0 to 1. So if you imagine 0 is down here, 1 is at the other end of the, basically 0 is at the start point, 1 is at the end point, and then anywhere along this line is a number from 0 to 1. So right now it's 0.81. If we take this and drag it back, now it's 0.48 because it's near the center. 0.75. If we go like a quarter way, it's close to 0.25. And you can manipulate this to whatever you want. And you can also add a parameter to that. So what we'll want to do is associate a parameter to it. We'll just call this, since this is at 0.75 right now, we'll call this NCP high. Make sure it's a type parameter, hit OK. And then for each one of these, double check. Make sure that, yes, indeed, this is closer to the higher side of the line, essentially the reference line. And then associate those to them. Aha. And then this is where you want to make sure that, that the number that it's associated with is, in fact, on the high side. So this number is on the low side. We still want it on this side, but the way that this reference line is created, the start is over here, 0 is over here, 1 is at the end, and so we want it to be on the lower side. So what we'll do is create another parameter called NCP low. Same thing, type parameter, press OK. And then what we'll do is go into the family types, and I think we used formulas last time, but just like this, we will do a 1 minus NCP high in the formulas tab. And what that will do is take the whole number 1, subtract whatever the NCP high is, which is 0.75, and it will give us essentially the exact inverse of the NCP high value. So if we change this to 0.8, it'll be 0.2. If we change it to 0.6, it'll be 0.4, et cetera, et cetera. We want to do that so that all we have to change when we go in and when we start setting up these scripts, all we have to input is a number into the NCP high value, and it will automatically update the NCP low value. And it'll be essentially fully parametric. So the last one, again, this one is at the lower end of the curve, so we'll hit the NCP low, hit OK. And then what we will do is select each one and do a spline through points, reference line, just like we've been doing. forgot to make this a reference line. Let's do that. All right. So, for some reason, didn't do it again. There we go. All right. So what we've done now is essentially created a rotational geometry. So if we minimize this a little bit so we can see it, and then we start to manipulate the NCP high, it will start to rotate that panel. All right. And then one additional thing that we can do is we can create a little offset. So we can bring the panel, make the panel a little bit smaller. So one thing when I start to manipulate and when these adaptive panels, either pattern-based or these generic model adaptives, they can get a little complex and a little convoluted with different elements. So what I like to do, you can't truly hide things, but you can temporarily hide them. So you can go to the bottom, hit hide element, and then you can start to simplify what you're working on and only focus on the specific elements that you're trying to manipulate. So do that. Maybe hide the nodes around there. All right, and then last thing what we'll do before we create a form is do 2 nodes on either side, and we're gonna put these NCP low. Actually, what we can do is we'll create a new parameter, offset low. Let's just create another one, offset high, while we're in here. So this is the low one, so offset low, offset high. Oh, I might have. Oh, go back in. Let's do the same thing. 1 minus offset high, so that they are reactive to each other. All right, press OK. So yeah, 0.8, 0.2. All right, offset low and offset high. Okay, and then what we can do, same thing, spline through points, make reference line. Spline through points, make reference line. All right, so now we have the offset from this side. What we need is now the offset from the other side. So we'll place 2 points on these newly created reference line. And now this time we can apply the same offset values to these. So offset high, offset low, offset low, offset high. Now we need to create, and this is where it sometimes gets confusing, so I'll temporarily hide these so they don't have overlapping reference lines. We want to create reference lines for an entire border because this new interior border will be what we create the form from. Spline through points, reference line. All right, so now we have this guy. It's adaptive. Now what we can do is select the two borders, the border of the overall panel and the border of the new smaller rotated panel. Create a form. And now what we can do, so there's a couple things before you load, like we have it completed, it's done. So what you want to do before you load it into the panel, or into the project, excuse me, and apply it to the surface, is make sure that it's actually adaptable, make sure that everything is linked to one another, and make sure that the parameters are doing exactly what you want to do. So what I first do typically is I'll go in and I'll start adjusting the different parameters to make sure that everything is reacting the way it's supposed to. Okay, so the twists are working. Then the offset is also working. Now I think, so one thing to be aware of, I believe if you're trying to do 0.5, yeah, so if you look at 0.51, let's say. So this is essentially saying that 0.5 is the greatest this value can be. So when we're setting up, because otherwise if it's greater than 0.5, or if it's 0.5 or lower, if this offset high value is 0.5 or lower, then it will fail, because the panel will essentially be offset too far inside and it won't actually create a panel. So this is good to know. We could set up an if-then statement in this family types, and I'll go over that a little bit later in the class, in the semester. But all we need to know is that we can't do that. We can't have 0.5 or lower. And when we go to set up our parametric scripts and we revalue the whatever kind of parameters that we're playing with, we just need to know that it can be only, this value can only be 0.501 or whatever, and greater to 1. So just, you got to keep that in the back of your head. You got to know that you can't set this specific parameter anywhere lower than 0.5. But these are working. The offset itself, let's do like 1. So it's lowering. Let's like just put it up to 10. Yep, it's working there. And then the last thing after you've checked your actual your parameters that you created is just go and drag these nodes around. Oops. And make sure that your geometry of the panel is reacting to that, because these are what, as I've said before, are going to actually create, these are what is essentially going to manipulate themselves to whatever surface that you have. So now that we know that it's manipulatable, it's able to be manipulated, and the parameters all work the way that we envision them, we can go in, save this as wherever we need to. So we'll just call this adaptive panel for right now. Oh, and one thing I wanted to point out too. So this is a, obviously a solid. You can add, void extrusions if you want to have some thickness to this. You could create a couple more reference lines and create a void form to create some thickness to this. Or if you just want to poke a hole through it, you can, for example, if I just created a hole in the middle of this panel. Oops, that's not a circle. I can create, a void form through this thing. And back down. Right, and now I've created a hole. The problem with that, and if you do any kind of void extrusions or try to create thickness, remember that it must, I was gonna say it must, I guess it's because I referenced this top face, so anywhere that this top face goes, it will shift itself. But I believe, if we made this panel way smaller than that hole, then we're gonna, cause issues. So make sure that whatever geometry that you're placing in here is reactive to those 4 nodes, or however many nodes that you created. So we've saved it. We can now load it into the project. I believe it's project 2. Yep. Okay, and we can just cancel out this right now because we need to go back into our 3D view, edit our conceptual mass, and now to place our newly created adaptive panel, we'll go to the Create tab and then go to the Component tool, place a component, and that should pop up. And then we essentially have to select the nodes, and it should, there you go, should, give you an example, make sure that the circle with the X through it is selected. Now that you have that placed, now you have the panel located on the pattern. We can probably adjust some of the parameters. Sorry, this is in another window. I changed the offset to 2 feet. All right. Now, you're probably, before I get into that, if you have it placed and you want to repeat this pattern across pretty much every instance along this surface where these conditions are met, where this node are the same, up at the top where there's typically an array button under modify, there's a repeat tool. And if you select that, it's going to repeat this pattern at every single instance along. And for some reason it did this at the bottom, which is kind of weird. But it will repeat it along that face. And if you want to, like for example, I don't want these down at the bottom edge. So what you can do is just go up to the top, hit remove repeater, and it will then let you select individual panels and manipulate them. Now you're probably wondering, and let me change this to shaded real quick so it's a little bit more apparent. And turn off patterns. There you go. So you're probably wondering, well, why would I do this if I can just create a pattern-based family that does this exact thing? Well, the reason for this, and if we undo and just go back to our original pattern and turn this off again. All right, so the thing that you can do with this is you do not have to prescribe to the pre-existing pattern or the series of nodes that are built from this pattern. You can apply this to anything. So anything that has 4 points, essentially, or however many points that you put in your adaptive generic model. So if you do place component again, and then select a point, you don't have to go to this next corresponding one. You can go down here, go here, and then maybe go here, and have your panel be like that. And if you do the repeating again, you're only basically on this specific surface with this amount of points. This condition where we've selected the points are only available in one other position, so that's why it's only repeated twice. But the other nice thing too is if you do, and this is what I'll be asking you on the homework, is if you select all of this and then repeat this across the face. All right. And then, so this does every odd. What you can do is go in and do the other rows, essentially. Make sure that you're selecting the node once again. If you select, because you can kind of select off the face like this, and then it will still place, but it will be obviously weird, and it won't adjust. If you end up manipulating the surface again, it won't update to it. So make sure that when you're placing these, you are selecting the nodes themselves. Oh, the other nice thing, so you don't have to start at the same place, right? So if I wanted to have the inversion of this, like if I want one row of panels rotating one way and then the other row of panels rotating the other way, I essentially can just select the points in the opposite manner, starting at the bottom instead of the top. Of course, that will then put this on the opposite side, but all you need to do if that happens is go over to the right side of to the properties and hit flip, and it'll flip it to the other side. And then once again, hit repeat. It will repeat that across the facade at every instance, so it'll infill. And then what I'm going to ask you to do in the homework is create an additional panel for the edge conditions. And that can be, you can add some parametric parameters. You can add some parameters into that panel if you want, but realistically it can just be a simple extrusion. But it's going to need at least it's going to need 3 nodes so that you can place it on these edges and have a nice clean edge. Because I know a lot of you were having issues when you're creating the pattern-based families that sometimes if the geometry of the surface was too complex, or if certain things weren't working nicely within Revit, it was kind of just extending the panel out and not giving you that clean cut. So this way we can make sure we can build our own edge panels and be a little bit more prescriptive about it. So that, I believe, is everything. Now if we go in and edit the parameter, right? So if we make it 5, I wonder if this will do all of them or just, yeah, so it'll do all of them. And then if we do a rotation, so go down to the bottom, and then our rotation, remember, is the NCP, so we can build 0.8. And they're all rotating pretty nicely. So yeah, so that is how to do your adaptive generic models. I'm trying to think if there's anything else that I haven't shown you guys. I don't believe so. So as always, feel free to email me, ask questions. I'm on for class for the 2 hours, 45 minutes anytime, or email me and we can set up a call or work through the issues over email. All right. Thanks. Have a great day.